So hello guys, my name is Shivam Pandey and you are watching me on Discover and Uncover YouTube channel. And today we are here with an again a very important and a very good concept of data structures, which is tree. So in last lecture we have studied a different concept, but here we are going to start with the concept of trees because it is a very important unit of your DS syllabus, and it is a fourth unit. We are doing the first unit parallelly, and we are starting with the fourth unit as well because I think so that if someone wants to study this unit fourth first, because it is an independent unit and the concepts are easy here. And if I compare it with the other units of your AKTU syllabus, then I think so. Then it is comparatively easy than your first unit and the second unit. So if you want to start, you can. If you want to start, then you can start from this unit as well, and you can parallelly complete that first unit parallelly. Yeah. So let us begin with the introduction of trees. So a tree. So let us first read the definition of what we have the content here. Then we will try to just summarize it in our own word, and you will get to know that what exactly the things are. So the thing written over here is that a tree is a non-linear hierarchical data structure that consists of nodes connected by edges. So here we are getting something that a tree is something that connects something. Yeah. So by reading this first two lines, we are getting imagination in our mind that a tree is a data structure that is connecting nodes that consists of nodes which are connected by some edges. We basically do not know right now that what are these nodes and edges. So yeah, so we'll just figure it out in some time. So now let us see that different tree data structures allow quicker and easier access to the data as it is a non-linear data structure. Yeah, so here we have been given a figure. Here we can see some numbers 1, 2, 3, 4, 5, 6, 7, 8. All these numbers are enclosed in some circles, and these all are connected by some these lines. And we exactly do not know till the time that what these lines are and what these circles and numbers denote. Right. So now let us see the now let us just break this suspense and let us know that what are the things right now. Yeah. So these circles, or you can say these things, these circles denote that these are nodes of the tree. Now, what is a node? So if you see a tree, then you see that there are different like branches of trees, correct? So different branches of trees are there in the tree, but if you come in the data structures, then we make these different branches as we name them as nodes here. Right. So these 1, 2, 3, 4, 5, 6, 7, 8, these are nodes of the tree. So nodes are the like I would say the building blocks of trees. So it is not the correct definition to be written in the exams. I'm just explaining it to you so that you can just memorize it and you can imagine it in your brain. So these are the nodes. This is the only the naming of this uh, these circles as nodes, and you can imagine that these nodes are the building blocks of the trees. And when we connect these nodes, different nodes with some edges, basically these lines which are connecting these two nodes are called edges. Yeah, so if we move further in this trees, we will know that this is called the root node. The uppermost node of the tree is called the parent node, sorry, root node, and the two edges by which these two nodes are connected, 2 and 3, are called the child nodes of node one. So basically, it is the parent node, which is also called as the root node for the uppermost node of the tree, and the two nodes connected by the parent node is called the child nodes. So this 2 and 3 is the child of parent 1, and parent 1 is also the root node of this whole tree. And if we come towards 2, then we see that here also 4 and 5 are the children of 2, but 2 is not the parent node, root node here. 2 is again a parent node, but not a root node. Root node will always be 1 for every tree. Correct? So each tree will have one root node, which is the uppermost. Like here, we are having one as a root node. And every other node which is having some children or which are having connections or which are having some nodes are called as the parent nodes. Here also 2 is the parent node. Here, if we see that 3 is not having any children, yeah, so it is not a parent node. It can be a parent node, but it do not have any children. Yeah, so that's the concept. And in this, our node can have as many number of children as much as possible. It is there is no foundation to have children, a number of children. It can be like six, like six can also have 4 to 5 children nodes. It is not any there are not the rules to make a tree, but we will have rules if we study further in B trees, behavioral tree. There are several rules which we have to remember to make them. So now let us see the properties of trees. There is one and only one path between every pair of vertices in a tree. A tree with n vertices has n minus 1 edges. So let us now discuss these 2 points. So there is only one and only one path between every pair of vertices in a tree. As you can see from the diagram, that there is only one vertices, that these two nodes are connected by only one this edge, right? We do not see we do not see in this diagram that one node is connected by two edges. We it is not seen in this diagram, right? We do not see that two is connected by three also and one also and and four also and five also. One node is connected by only one edge, correct? So that's the idea behind it. A tree with n vertices has n minus one edges. So now let us see that the point here written is valid in this diagram or not. So let us now calculate the number of vertices in this figure. So vertices is nodes again, and it is the same as the number of nodes. So now let us count the number of nodes. There are 8 nodes in this diagram, and we see the number of edges: 1, 2, 3, 4, 5, 6, and 7. Yeah. So number of nodes or vertices is 8, and the number of edges is n minus 1, that is 7. So this is again a valid point, and it satisfies the diagram we have taken. Satisfies our this thing. Yeah. So a graph is a tree if and only if it is a minimally connected. Yeah. So here it is not. We are calling this not as a graph, a tree, but as a graph. So any connected graph with MNOs so we will learn about this concept of graph further in the further lectures. So now discover the tree applications. So we will study these points in the further lectures, the BST, binary search trees, and everything we will discover in the future. So now let us don't go about the BSTs because it will be very much like chaos, and it will create confusions in your minds that what is BST and everything. So you have to wait a bit to just know about these things, and so we are skipping the applications as of now because we have to wait for the right time because we have to discover these things. We have to learn these things when we'll reach the topics there. Most probably we will start BST in the next after next 2 classes. We will start this concept in the third class. Okay, so where there are some terminologies which we see in trees: node, edge, and root. Yeah. So node, I've already taught you that what is a node. It is the building blocks, so you can say that contains a key value or anything pointer to the child nodes. So they are called the nodes. I've explained. I've taken a lot of time to explain you that. And edge, what is an edge? Edge connects the two nodes, or and root also. I have explained you that it is the topmost node of a tree, right? So these things are very much understood by you all. And now let us see that what is a root node. So root node is the uppermost node of the tree. So here we are having root node as A. As you can see, that is the uppermost node. And if we compare level wise also, then it is level 0, level 1, level 2, and level 3. So the topmost level at which the root node is there is level 3, and it is a root node. Yeah, it is again a very important point is written in the point number 3. We can never have multiple root nodes in a tree data structure. Yeah, so always remember that you can't have multiple root nodes in a tree data structure, and there will be always a root node and one and only root node for every tree you make. Now, so let us know about edges. So the connecting link between any two nodes is called as an edge. Yeah, so I've already told you the same concepts are being repeated, or they are just written for your sake of information. Yeah, so they are the things. Now let us see the parent. What is the parent node? I've already taught you that A, as you can see from the image, that A is the parent of B and C. For the sake of exams, let us now see that what definition is given over here. The node which has a branch from it to any other node is called as a parent node. Yeah. So if we have A and if we have B, then B is also a parent node and it has branches as D, E, and F, and it is called a parent node because it has some children associated to it. Correct. So in a tree, a parent node can have any number of child nodes. In a tree, a parent node can have, yes. So I've already taught you that a parent node can have as many number of children as it requires. There's no foundation or some rules associated to it, and it can have as many number of children as it need, and there is nothing wrong in it. Yeah. So child. So this is the same thing which are getting repeated. So child of A, you can see C is the child of A, B is the child of A, D is the child of B, E is the child of B, I is the child of E, J is the child of E, A is the child of G. So these same things are written here in the right side of the page. You can see. And what are siblings? Now, some points are there in this concept that the words are very similar to each other, and some people often get confused that what are siblings, what are children. Yeah. So basically, in our families, if we see that what does sibling mean to us, that if you are, let's suppose, if you have your father is having a brother, and your father are two brothers, and then your father's elder brother or younger brother, anything, the children of your father's elder brother or his younger brother, the children of the children of your father's elder brother will be yours siblings, and also your brother or sisters are like siblings to you. Yeah. So now let us see what are siblings. So yeah. So if we see that A is having children as B and C, and we can say that B and C are siblings, and because so now let us see why we are calling as B and C as siblings, because they are having the same parent. Yeah. So B and C have the same parent A. Correct. Now let us see degree. So, degree is also a very important concept in the this tree. Degree of a node is the total number of children of that node. So, for now, you take it as the degree means that. number of children associated to a particular node. A is having like two children, B and C. So the degree of node A is equal to 2, and they are having two children, B and C. So degree of A is 2, degree of B is 3 because it is having three children, D, E, and F. Degree of C is G and H, and degree of G is only 1 because it is having only one children. So let us move further and know what is internal node. So the node which has at least one child is called as an internal node. Internal nodes are also called as non-terminal nodes. So now let us see that internal nodes are the nodes which has at least one child. Yeah. So if we see here in the diagram that every node is having at least one child, yeah, except the nodes D and H and I, J, and K. Except these nodes, every node is having at least one child, one children. So every non-leaf node is an internal node. Yeah, so it is the concept. So yeah, so it is the concept behind the. It is also written over here that A, B, C, D, E, and G. A, B, C, D. How come G? Sorry. E, G are the internal nodes, and yeah, so it is the concept of internal nodes. Now let us see what are the leaf nodes. So the node which does not have any child is called as a leaf node. So it is a very obvious thing from the definition itself that node which do not have any child is called as a leaf node. Here you can see in the diagram that H, D, I, and J do not have any children. So we call them as leaf node, or they are also called as external nodes or terminal nodes. Terminal nodes because they do not have any children, and tree is terminating over here. The continuation of the flow of the like tree is breaking over there, and tree is terminated at this point. Yeah. So now let us see the level. Now see in the diagram, we have been given the same diagram, and we are seeing that A is at level 0, B and C are at level 1, and level 2 and level 3 simultaneously. So why is it so that the uppermost layer is being counted as level 0? Now, question must arise in your brains that why this bottommost layer is not as the level 0, and why the topmost is the level 0. So the simple idea behind this is that the uppermost layer is the root node is taken as level 0 because it becomes easier for the calculations further, like taking out degree of the tree, like taking out the height of the tree. So it becomes easier if we take the uppermost root node as the level 0. Yeah. So it is the idea behind it. Now see what is the height of the tree. So height of the tree, the total number of edges that lies on the longest path from any leaf node to a particular node is called as the height of that node. Yeah. So if we see that what is the height of the A, so you can see that height of the A is you can see the number of leaf nodes. So, if we compare the length of A roots, we can see that A is having a child C, C is having child G, and G is having child K. So, 1, 2, and 3. So, basically, height of A is that starting from that node where till where we can reach to the end of that node, and basically we have to reach the terminating node from the root node or the node we are considering to calculate the height, that height of the node. So A has the height of 1, 2, 3. So A has height 3. C has height 2. Correct? So you might be wondering that C here has only one node here, one sub node here, and the two here. So which one will we consider, the right one or the left one? So we have to take the maximum number of or we have to take the longest path to calculate out the height of the node. Yeah. So in this diagram, we can easily see that C, the longest part is from C to G and to G to K. So the longest part is C to K and it has two child nodes. So the height of the C is 2. Height of H is 0 because it do not have any children here. So it is 0 obviously. B has a height of 2. E has height of 1. E has height of 1, yeah. So F do not have any height 0, and D also has height 0. Yeah. So coming forward, we have depth. Yeah. So total number of edges from root to a particular node is called depth of that node. Yeah. So that depth denotes that total number of edges from root. For example, if we take A and if we root node to a leaf node, yeah, so correct. So we are considering that we are taking A as a root node and we have to consider the height or we have to take a distance from a root node to the to any other or to every node of the tree diagram. Correct. So if we are taking A, then height of A is 0 and from A to A we have distance 0. So the depth of node A is 0. If we take node B, then you can see that we are moving from A to B with one single edge, and it is called depth of node B is 1. Depth of node C is 1. Depth of A to E, or you can say from root A to root E, will be 2. Yeah, so we can see that it is 2. Now, if we calculate between the depth of K, the depth of K from A will be 3. Yeah, so it is 3. It is very much obvious that it is 3. What is subtree? So in a tree, each child from a node forms a subtree recursively. Each child node forms a subtree on its parent node. So if we see here, then A has two children, this whole part, this whole part. So these are the subtrees of A. This whole part again in the right side and the left side, both are the subtrees of A. B has also subtrees D and E. E has also subtree I and J. Sorry. I'm really sorry for this. B do not have subtree as D and F. In this case, if we can't divide the things into equal halves, we can't decide that what exactly are the subtrees. Yeah, so you will get to know about this thing in the future that how to divide the tree if we have three states or three child nodes for a parent node. Yeah. So a forest is a set of disjoint trees. Yeah, so he see there that there is no link between this tree and this tree. So these are the trees which are not connected to each other, and we can see that these are disjoint. They do not have any common connection. So these are the disjoint trees, and these disjoint trees, while we denote them as forest. Now, for this lecture, we are keeping uh, till this only the definition and the terminologies of tree. And in the further lecture, we will take the types of trees. I will definitely tell you about what are the different types of trees, and we will explain the key concepts between these all trees. General tree binary tree. Yeah, so that will be your next lecture soon. And thank you for being cooperative. And yeah. That's all for now. Thank you.